Welcome. In this video, we are going to discuss about NEET 2001 previous year question in physical chemistry under the topic of some basic concepts in chemistry. Let's discuss. In this year, totally three questions are asked. So let's discuss. Molarity of the liquid HCl if the density of the solution is 1.17 gram per cc. This is cc. Okay, that is a mistake. This is cc. Is they give one density, they are asking molarity. There is a no interrelation, like, right? But there is a relation, indirect interrelation between these two. We need to find that relation so that we can find the molarity. This is so easy. What do you mean by molarity? Generally, the molarity is equal to number of moles divided by volume of the solvent in liters. Volume of the solvent in liters. This is molarity. Okay, we are going to find the number of moles. That is our key. Number of moles is nothing but given weight divided by molecular weight. This is a formula for number of molecules, sorry, number of moles. Given weight is what? We don't know the given weight, so there is a only one formula. Rho is equal to m by v. According to this formula, m is nothing but a mass. Mass is nothing but a given weight. Okay, mass is a given weight. Molecular weight is a constant, but this mass is not a constant. This mass can be vary. So to find m means mass, we can find also the given weight. So m is equal to rho multiplied by v is equal to m. Okay, what is rho, then what is v? V is nothing but 1000 ml in general. 1000 ml or else 1 liter. In generally, if we take anything, it is nothing but a 1 liter or 1000 ml. Okay, density is nothing but 1.17 multiplied by 1000 ml. It will give the given weight or else mass. I am taking it as a given weight. Okay, given weight. Molecular weight of HCl is, everyone knows. Molecular weight of chlorine is 35.5. Molecular weight of hydrogen is 1. So totally molecular weight of HCl is 36.6. Okay. Let's solve this. Okay, then molarity is equal to, given weight is what? 1.17 multiplied by 1000. This is given weight. Molecular weight is 36.6 in liter. Okay, there is only one twist. If we solve this, okay, if we solve 1.17 multiplied by 1000 divided by 36.6, it will result in 32.05 something. But there is a liter. This liter cannot be included because molarity is nothing but number of moles in a 1 liter or 1000 ml. That 1 liter or 1000 is standard or else constant, so do not include that in the calculation, which means to find the molarity, because it is always constant. Okay, but in this case, rho is equal to m by v. In this case, it should be added because in this case volume can be anything, so I am taking it as a 1000 ml because of the standard condition. But here it is always standard, so do not include this. Okay, from density of a solution we can find the molarity easily. There is a two things to know. One is molecular weight of the liquid, and another one is nothing but what is a way to find the molarity. Okay, do not include this liter because it is standard. Okay, let's discuss the next question. Okay, this is one of the, I think it is mentally it is very tough. Okay, percentage of selenium in peroxidase anhydrous enzyme is 0.5 percentage by weight. Okay, the minimum molecular weight of peroxide anhydrous enzyme. Okay, they are asking the minimum molecular weight of peroxide anhydrous enzyme. They given percentage of selenium in the peroxide anhydrous enzyme, but percentage of selenium in how much moles of peroxide anhydrous enzyme is not given. We need to find minimum molecular weight, which means 1:1 ratio or else any ratio, but it will be the minimum. No peroxide anhydrous enzyme beyond that. It is a minimum. What is minimum? Okay, there is a one formula to find this, which is nothing but we only solve by selenium. Selenium is one of the component of anhydrous enzyme. Okay, this is a clear. Okay, which means percentage is 0.5, which means percentage of selenium, it is nothing but percentage of selenium, which means selenium is at least present in only one atom. At least it will present as a selenium, not a selenium 0 point something. It will should present as a selenium atom, at least one. So one atom means there is a 1 mole of selenium. So 1 mole of selenium in this enzyme, 1 mole of selenium in this enzyme, which is divided by minimum molecular weight, which is nothing but a minimum molecular weight, multiplied by 100. Why I'm writing this formula? Because percentage of selenium is nothing but at least only one atom of selenium should be present in minimum molecular weight of enzyme. Kindly note, I'm repeating again, percentage of selenium is nothing but at least only one atom of enzyme, sorry, only one atom of selenium should present in the minimum molecular weight of peroxide anhydrous enzyme, because selenium is in the percentage of 0.5. So that I am writing this equation. From this we can easily find the minimum molecular weight. Okay, what I am wrote is nothing but I'm writing in a clear manner so that we can understand. Okay, percentage, which means 0.5 percentage of selenium is equal to 0.5 percentage of selenium is equal to 1 mole or 1 atom of selenium in the enzyme. Okay, 1 mole or 1 atom. Okay, 1 mole or 1 atom, I am taking as a 1 atom selenium in that enzyme divided by minimum molecular weight. I am taking it as a mmw because of the convention, because it is too large. So mmw, we need to find the minimum molecular weight of enzyme. Okay, this goes here, then 0.5 comes here. Sorry, there is a multiplied by 100, it will present. Okay, so the mmw, which is equal to, what is one atom of selenium? It is 78.4. One atom of selenium is 78.4, 78.4. So that it is given. Okay, so that it is given as a given data. So 78.4 divided by 0.5 multiplied by 100, the answer is nothing but 1.5 into 10 to the power plus 4. Okay, so the answer is option A. This is how we need to solve this problem. This is one of the mentally tough. Okay, simply think, there is a 0.5 percentage of selenium in weight. The selenium should be present as a one atom in the minimum molecular weight of enzyme, which is multiplied by 100. Why I am multiplying by 100? Which means I need to convert into percentage. So that, okay, we need to find this. So it goes here, then this comes here. We need, then we solve. This is the answer. Okay, this is very easiest question, but it is mentally very tough. We need to understand the question first so that we can solve it. This is the last question. Okay. Specific volume of cylindrical virus particle. This is full of mathematics. This is cylindrical virus particle is 6.02 into 10 to the power minus 2 cc per gram, whose radius and length are given. Avogadro's number, if Avogadro's number is 6.02 into 10 to the power 23, find the molecular weight of virus. They are asking the molecular weight of virus. How to solve this? This is full of mathematics. Okay, but it requires only one formula because it is a cylindrical size. Okay, we need to find the cylindrical volume. That's it. We need to find the cylindrical volume. Okay, this is very simple. Okay, the specific volume of the particle is given. This is a specific volume. This is specific volume is given. Then it is a cylindrical virus, so that we can find the cylindrical volume. Okay, to find the cylindrical volume of a virus is nothing but pi r square L. Okay, what is pi? 3.14 is pi. What is r? R is radius. Radius is given 7 Armstrong, so 7 square. What is length? L is, okay, what is L? L is nothing but a length. It is given 10 Armstrong. Okay, 10 Armstrong. So Armstrong need to be converted into centimeter. Okay, because it is nothing but a cc is nothing but a centimeter cube. Cc in the, it's nothing but a centimeter cube. Okay, we need to convert into Armstrong into centimeter. Okay, Armstrong into centimeter, it is nothing but 10 to the power minus 8. 10 to the power minus 8. So 10 to the power minus 8 whole square. Okay, if we solve this, volume of the cylindrical virus is nothing but 154 into 10 to the power minus 23. This is centimeter. Here it is a centimeter square. Then here it is 1 centimeter. So this it is nothing but a centimeter cube because this contains Armstrong square. So centimeter square. This is 1 Armstrong, then centimeter, so centimeter cube. Okay, centimeter cube is nothing but a cc. Okay, we have volume of the virus in centimeter cube unit, cc unit. Then also have the specific volume of the viruses in cc. Then we can solve the answer very easily. How to solve this? It is very simple one. Okay, if we take ratio, we can solve it because molecular weight is what? Molecular weight is nothing but total weight, which is nothing but a molecular weight is nothing but a 1 mole. Molecular weight is nothing but 1 mole multiplied by Avogadro's number, because 1 mole of a substance contains 0.623 into 10 to the power minus 23 molecules. That is a molecular weight of a virus. Okay, so that we can find the what is called moles. Okay, we need to find the moles because molecular weight is nothing but moles into Avogadro's number. We need to find moles. Moles is nothing but what? Given weight divided by molecular weight, which means given volume divided by specific volume. Like this is a given volume. If we divide this with the specific volume, if I divide this volume with the specific volume is 0.62 into 10 to the power minus 2, 0.62 into 10 to the power minus 2. This is also cc per gram. This is also cc get cancelled, gram goes up. So the final answer, then we have to multiply by Avogadro's number. Okay, I'm collectively I will collectively write here. Okay, we solve this and multiplied by Avogadro's number. We have the answer is nothing but 1.54 into 10 to the power. Okay, so, sorry, that there is no 10 to the power. Okay, it is nothing but 1.54 kilogram per mole. Okay, the idea is nothing but we need to find the volume of the cylinder pi r square L. Then we have a specific. Given volume divided by the specific volume gives some value, which is multiplied by the Avogadro's number. It is nothing but a molecular weight because the given volume and the specific volume is like a moles. If we multiply the moles with the Avogadro's number, we end up with the molecular weight. That is the idea. Okay, these three questions are mentally very difficult, but it is easy to solve once we understand.